Hey guys, Mr. Noon here, and I was going to do a quick little practice problem for you with displacement, position, and time graphs. All right, let's get to it. All right, what do we got? So here's our question. A bug takes off at a constant velocity of 5 meters per second. And then 1 second later, a car takes off at 12 meters per second. The car eventually catches up to the bug where it splats on the windshield. Ooh, tough day. Using a graph, show the approximate distance and time where the collision occurred. Well, there you go. This is just simply making a position time graph and then looking at where those lines intersect. So let me show you a couple of tricks on how to do this, and should be able to have no trouble at all, I'm sure. All right, so let's go ahead and make our position time graph. I'm just going to draw it on here. I'm going to show you how I'm going to make sure my answers are correct, but I know I need some 5 and a 10 and 20 and, oops, should be 15, right? 15 and maybe a 20. I'm probably going to need a 1, 2, 3, 4. That should be good enough. All right, so I know that the first guy goes 5 meters per second, so 5 meters, and this is my distance, and of course this is my time in seconds. So 5 meters per second, which means it'll be at 10 meters in 2 seconds. And there you go. So just like I do, make sure your graph is perfectly drawn to scale and proportion. And make sure that your lines don't curve at all, that you use a ruler and so that they look really straight, a lot like mine does. Okay, so the next one we saw left, or the car left 1 second later, and it was going 12 meters per second. So we're going to be starting here. So 1 second later it left, and so we're going to go 12. So in 1 second it was up to 12. See, this is probably about where 12 is right there. Okay, so from right here to here, we go cut-a-boom. All right, so there's our collision point right there, or you could also call it the death point of the old bug. All right, so here we go. Now that's pretty rough, and so I can tell that my collision point is somewhere below 10, so 8, 9, something-ish. And then my time is somewhere close to 2, but not quite 2. So, so I know that I'm going to be less than 2 seconds, just a little bit. And, somewhere around, 8, point, 8, I don't know. I'm just making something up right now as far as my distance and time. So there you go. Now, how would I actually make sure? Well, I would probably just graph this in my calculator to double check. And so what I'm going to do is I'm going to just figure out my y-intercept equations on these two lines. So I know that one of them, this one right here, has a y-intercept of 0 and has a slope of 5, because that's what the velocity is. The velocity of a position time graph is its slope. Now the other one, I know that the slope is 12, but I don't know what the y-intercept is. So I could take this one point and stick it in here if you remember how to do that. So this point has a coordinate of, this point right here has a coordinate of 2 and 12 for that first point right there. So I could stick that in there. I could say, okay, 12 equals 12 times 2 plus b. So then b equals negative 12 if I solve that out right there. So you could do that. You could also think, if it passes this, positive 12 here and mirror down there, it would cut through negative 12. This is probably a good way to do it. Go back to some of those rules you got right there. So, I'm going to go ahead and throw in my my y-intercept is going to be negative 12 on that line. And then what I could do is I can open up my calculator, make sure my window's good. All right, so I can open up my calculator to my y equals, and I could say one of those lines is 5x, and the other one is 12x minus 12, and I could graph those two bad boys. And there they are. That looks exactly like the one I drew. I don't know why I should have to do it like this, but it looks exactly like the one I drew. So I'm going to go to, let's see, second calc, I think is what it is. Intersect, boom, boom. And there I got my intersect. So 1.7 and 8.6. Ooh, that was pretty close. So 1.7 seconds and 8.6 meters is my final answer. So any of these, intersecting kind of problems like that, you can go ahead and use a graphing calculator. You just got to get your y-intercept equation for your line, which you guys should know how to do. And if you don't remember, quick YouTube lookup will give you the skills on that. And then, of course, drawing it out. If you draw it out as perfectly accurate as I do, then you probably don't need to use the calculator. So there you go, a little heads up on how to do that, making it easy, making it simple, and so there you go.